Let's study the properties of the DTFT. The first, linear property. When you have x1 and its DTFT, x1 exponential j omega hat and x2n, x2 exponential j omega hat, then if the signal is a combination of x1, x2 with constant a and b, then its DTFT x exponential j omega hat is also a linear combination of x1 exponential j omega hat and x2 exponential j omega hat with constant a and b. So DTFT satisfies superposition property. The second one is time delay property. If yn is shifted version of xn by time nd, then its DTFT is x exponential j omega hat times exponential minus j omega hat nd. We can prove this property using the definition. Y exponential omega hat is yn exponential minus j omega hat n summation from minus infinity to infinity with respect to n. Let's put on this here the n minus d. We change the variable as here, then n is m plus nd. So multiplication of two terms we can express of exponential summation in exponent, so like this. So this is x exponential j omega hat. So proof is completed. Third is frequency shift property. When y exponential j omega hat is shifted version of x exponential j omega by minus omega 0, then its inverse DTFT will be multiplied by exponential j omega 0 n and xn. So we can prove this using definition DTFT. So here yn, so yn is exponential j omega 0 hat 0 and xn. So multiplication of two exponential can be combined in this, and instead of omega hat we can put omega hat minus omega 0. Yes. So compared to time delay property, if xn minus nd x exponential j omega hat exponential minus j omega hat nd, if there is x omega hat minus omega 0 will shift in frequency, then there is multiplication j omega hat 0 and xn. Okay. Here there's a 10 running rectangular pulse Hn is 10 amperes, and then the each dtft h exponential omega hat is like this. Then what will be the dtft of hn times cosine 2 pi over 5n? From Euler's equation, it will be a half exponential j 2 pi over 5n plus a half exponential minus j 2 pi over 5n. So due to linear property, it will be a half hn exponential j 2 pi over 5n plus hn exponential minus j 2 pi over 5n. You can separate the two terms from frequency shift property. Half h exponential j omega hat minus 2 pi over 5 plus a half h exponential j omega hat plus 2 over 5. So this is h exponential j omega hat, and here is the shift by 2 pi over 5. So only this part will be this. Another one, there exists like this. Look at that. So combining two signals and divide by 2, so this will be like that. And the next property is convolution and the TTFT. If there is convolution in time domain, in frequency domain, after TTFT will be multiplication of each DTFT. So the property says that the DTFT transforms convolution to multiplication. Here is proof. We already did it with FIL, a filter, the frequency response of FIL filter. We already studied this. So just I'm gonna introduce the proof, and I'm gonna recommend you study by yourself. The next one is possible theorem. The possible theorem means the total energy over time domain is same as energy in frequency domain over one period. The energy spectrum is the Fourier transform of time domain signal, which turns out to be an autocorrelation function, which is widely used in signal detection applications. The autocorrelation function is defined as CXX. Autocorrelation means correlation of two same signals, xn minus convolution xn. And so convolution is n minus k and times x minus k. Let's change a variable as this is m, then it will be n plus m. Actually, m starting infinity to minus infinity, but summation it can change from minus infinity to infinity. When you take dt of t, this dt of t, this, then exponent c x exponent j omega hat, and multiplication, so convolution will be multiplication, and xn will be x exponent j omega hat. Instead of n, when we put minus n, it will be minus j omega hat. That is complex conjugate. So x exponential j omega hat conjugate, complex conjugate times x exponential j omega hat will be absolute value square. The inverse dt of t integral, we can get time domain signal autocorrelation here. So when we put x and 0, the left side is here, so it's 0, then x square, and this is right side here. When n is 0, will be 1, so here's 1. So we can prove Passava theorem. Here is properties, so you can take a look to understand the pairs between time domain and frequency domain.